Okay, welcome back to our class. Today we will discuss the Laplace transformation using transformation pairs. So this is Laplace transform using transformation pair. Or we can say that this is using the tabular method. For today's learning objective, so we have here our learning objective. So at the end of the lecture, the students will be able to familiarize. Let's have this one, familiarize Laplace transformation pairs. All right. And of course, no, solve Laplace transform, solve Laplace transform of the function using transformation pairs. Okay, now before we start our discussion, let us review now of what we have discussed now yesterday. So this is the Laplace transformation pair table. This is the Laplace transformation pair table, and we will start with the Laplace transform of the Dirac delta function. So if you can still recall, let's have this as transformation number one. This is the Laplace transform of the Dirac delta function. Okay, let me erase this part first. So let's create a table. So this is your function of t, and over here will be your function of s. So function of s, as we all know, that is just the Laplace transform of your function of t. Okay, now let's start with our first transformation pair. Let's start with the Dirac delta function. Now, the Laplace transform of the Dirac delta function is equal to 1. If you can still recall, now that is equal to the value 1. Now, what about the Laplace transform of a unit step function? So this is the Laplace transform of a unit step function. Unit step function is defined by u sub t, or you can also call this as the Heaviside function for h sub t. So this is 1 over s. So the Laplace transform of u sub t is 1 over s. All right. Now, what about the Laplace transform? Okay, let's continue here. What about the Laplace transform of the linear function? Let's say the linear function is defined as t. That's the linear function. Can you still recall the Laplace transform of the linear function? Of course, this is 1 over s squared. Now let's have the quadratic function. So this is the quadratic function, or shall we say the second order function. So the Laplace transform is just 2 factorial all over s cubed. Now for The polynomial of degree n, the Laplace transform of that is n factorial all over s raised to n plus 1. So take note of that. That is very important. All right, now that is the Laplace transform of the powers of t. Now let's start with the exponential function. So I have here exponential function e raised to at. Now the Laplace transform of that is just 1 all over s minus a. If a is negative, like this one, is negative, the Laplace transform will become positive. Okay, that is for e raised to a times t. Now we go to the Laplace transform of the sinusoidal function. We all know that the sinusoidal function is sine and cosine. Let's start with the sine function first. So the Laplace transform of sine bt is just b all over s squared plus b squared. For the cosine function, the Laplace transform for that, okay, is just, oh, I'm sorry, this is s all over s squared plus b squared. That's for the cosine function. Let's have another one, this time for hyperbolic function. Now the Laplace transform of sine or the hyperbolic sine of bt is simply b all over s squared minus b squared. Now take note of this. Take note of the difference of sine and hyperbolic sine. They differ in the sign of your b, in your denominator. Okay, now let's have the cosine or the hyperbolic cosine of bt. Now this is s all over s squared minus b squared. Now for now, we will be focusing on this type of Laplace transformation. Oh, by the way, now before anything else, now let's take the Laplace transform of uh, the function minus the Laplace transform. The function equivalent to e minus as all over. Okay. So I think this will be all for the Laplace transformation pair. Now we have discussed this yesterday. So for today, now we will be solving problems related to this transformation pair. Now let's start with our first example problem. Start with example number 1. Let's label this as examples because today, we will just be solving examples and we will use tabular method to solve all of this problem. Let's start with our first example. Let's say Laplace transform is the Laplace transform of 5 and to derivate the function as 8 derivate the function minus 1. So we will be solving the Laplace transform of this function. Now to solve this solve the Laplace transform of this, we need to take the Laplace transform of each term. Let's start with the first term. So 4. Now 4 is actually a constant. Now if you will go back, to your transformation pair, uh, the constant is actually defined here. This is the Laplace transform of the constant. Okay, this is the constant. So meaning to say, the Laplace transform of a constant is simply 1 over s. Now, if the constant is equal to k, the Laplace transform for that is k over s. All right, now we go to, we will go back here. Now, if the unit step function is not defined, now it is always, the constant now is always multiplied by the unit step function. Okay, don't be confused on that. Now let's start with the Laplace transform of 4. So by inspection, the Laplace transform of 4 is just 4 over s. That is the Laplace transform of the constant. What about the Laplace transform of the Dirac delta function? So since 5 here is constant, we can just take out 5 and take the Laplace transform of the Dirac delta function, which is equal to 1, plus the Laplace transform of the Dirac delta function shifted by 1 unit. Since 8 is a constant, we can just take out 8 and then take the Laplace transform of the Dirac delta function shifted by 1 unit. So this will become e raised to minus ks, or this will become e raised to minus s. So this will be your answer. All right, so let's have problem number 2. So for problem number 2, we have this function. So let's solve this function. What is the Laplace transform of, let's have this one as 4t minus 3t squared plus 6t multiplied by a raised to 5. So to solve this Laplace transform, now we need to take the Laplace transform of each term. So we can write it as 4 times the Laplace transform of t. Take note, 4 is a constant. We can just take out the constant. In this second term, we can take out 3 and take the Laplace transform of t squared. Okay, the next term, take out 6 and take the Laplace transform of t raised to 5. Okay, now the Laplace transform of the first term is just 4, that's the constant, multiplied by the Laplace transform of t, which is equal to 1 over s squared. So the next term will be 3 times the Laplace transform. Take note of the Laplace transform. Take note of the Laplace transform of, recall this one, Laplace transform t raised to n is equals to n factorial all over s raised to n plus 1. Okay, so if n is equals to 2, this will become multiplied by 2 factorial all over s raised to 2 plus 1. So that becomes 3. So plus, we have 6 multiplied by, we have 5 factorial all over. So 3 times, 3, no, 5 is the exponent. So this is 5 plus 1. This will become 6. Okay, so I assume now this will be your answer. Just simplify this and you have your final answer. Okay, this is my answer, but for you, you have to simplify it first. Anyway, I will give an examination that is also a multiple choice problem. Questions, I mean. So let's start with another example here. Supposing I have here 1 plus 4t squared raised to the power of 2. So you cannot just take the Laplace transform directly, but you need to expand the terms. So in this case, now we are going to square the binomial. Square the binomial is just like squaring the first term, okay, plus multiplying the first term, which is 1, multiply the first term, the second term, and the exponent. So that will become 8. That will become 8t squared. Okay. plus we are going to square the last term, which is 16t to the power of 4. And then we are going to take the Laplace transform of the expanded binomial. Okay, now since we already know how to take the Laplace transform of each term, we can just directly solve the Laplace transform of this. Since 1 is a constant, the Laplace transform for that is 1 over s. And we are going to take out 8 and take the Laplace transform of t squared. That will become 2 factorial all over s cubed plus 16, and the Laplace transform of 4 factorial of t to the fourth is 4 factorial divided by s raised to 5. Okay, right now I think that this will be your final answer. So you can simplify this now, and then you have your final answer. Let's have another one. This time let's try trigonometric function. Okay, for the trigonometric function, let's say before trigonometric function, let's have the exponential function first. We can do the combination of both. Let's say I have here, this is a constant, plus we have 3t squared minus 4e raised to minus 2t, so plus 6 cosine of, let's say, 4t. All right, okay. To solve this problem, we need to take the Laplace transform of each term. So let's start with the Laplace transform of 4. We can say 4, the Laplace transform of 4 is just 4 over s. Since 4 is constant, now it follows that the Laplace transform of a constant is just constant all over s. Let's have the Laplace transform of t squared. So take out 3, and the Laplace transform of t squared is 2 factorial all over s cubed, and take out 4, and the Laplace transform of e raised to minus 2t. If you can still recall, the Laplace transform for that is s1 over s plus 2, and the Laplace transform of the last term, that is 6. Take note of the Laplace transform of cosine. This is s all over s squared plus 4 squared. Okay, you can simplify this, and that will be your final answer. Let's say 4 over s plus, we have 6 over s cubed. We have minus 4 all over s plus 2. We have 6s all over s squared plus 10. So I think this will be your final answer for problem number 4. All right. Now we go to our next example. This time we are going to solve problem problem number 5. All right. Now let's try cosine Laplace transform of, shall we say, sine of sine of 2t, then cosine of 2t. Take note, this is multiplication. So you have to take the Laplace transform of the product of cosine 2t and sine 2t. So most of you will do this. Okay, I will put it here. Most of you will do this, the Laplace transform of sine 2t and the Laplace transform of cosine 2t. Take note, this is incorrect. Okay, you cannot do this. This is not equal because that is incorrect. So this is a common mistake for the students who are beginners of Laplace transformation. Okay, now let's try the Laplace transform of this now by using identities. Recall that the identity, let's try this one. Recall that sine of 2x, let's use x, is equivalent to 2 sine of x cosine of x. Now, take note, this is the identity. Okay? Since we are given sine x and cosine x, now here, now in this case, the angle becomes 4 at 2x. Now, if we are going to double the angle here, this will become 2 sine of 2x and cosine of 2x. Now, on the other side, it will become also double. So we can double this out. This will become sine 4x. Now, take note, this is your sine 2x and cosine 2x. If we are going to divide the equation by 2, the result will be the Laplace transform of sine. So instead of x, I will just write 4t all over 2. So this is now the Laplace transform of the equivalent function above. So since 2 is a constant, you can just take that out and take the Laplace transform of sine 4t, which is equals to 4 all over s squared plus 4 squared, which is 16. Now to simplify the final answer, we have 2 all over s squared plus 16. So this will be our final answer. Okay, what number are we now? Let's say number 6. Okay, for problem number 6, let's do one more time. Number 6. Let's say I have here, for problem number 6, I have here sine squared of t. Take note, sine squared is not in the transformation pair table. So how are we going to do this? So we can solve the Laplace transform of this by using the trigonometric identities. Can you still recall your trigonometric identities? Let's try your trigonometric identities. Now let's start now by recalling the trigonometric identities. Let's start with the cosine function. Let's say, what is the uh, identity of cosine of 2x? So recall the identity of 2 cosine 2x is just cosine squared x minus sine squared x, right? Okay, now another identity for cosine 2x is when we change this one. Let's say we are going to change this uh, into, okay, let's copy this one, and we will change sine squared x to 1 minus cosine squared x. Now we have what? We have 2 cosine squared x uh, minus 1. Take note, this will become cosine squared x minus 1, which is equivalent to cosine of x. Take note, this is your identity back in your trigonometry. Now, if we are going to no, manipulate this term by transforming this negative 1 to the other side of the equation, you will have 2 cosine squared x is equals to cosine 2x plus 1. That will become positive. Okay. Now, if we are going to divide the equation by 2, okay, let's rewrite it in this manner. If we will divide this by 2, now the result will be cosine squared x. Now I will write it in this manner. Cosine squared x is equals to 1. I will write 1 first, plus cosine of 2x all over 2. This is actually the identity of your cosine squared x. Now you can also do that now if now you want to change this function into 1 minus sine. So let's try. Now so we have one identity. This is the first identity for cosine 2x. Okay, and this is the identity for cosine squared x. Now let's try now sine squared x. Now the identity of sine squared x can be derived from this equation. Okay, let's try to derive that equation. We have cosine 2x, but this time we will change cosine into 1 minus sine squared x minus sine squared x. So simplifying further, this will become 1 minus 2 sine squared of x equal to cosine of x. Now, if we are going to transpose this term to the other side of the equation and divide it by 2, this will become sine squared x. And what will remain here is 1. This cosine squared, this cosine 2x will be transferred to the other side. That will become negative, and divide the whole equation by 2. Oh, so that's it, no, for the identity of sine squared x. That is why, no, it is very important, if you know how to derive the formulas, because you don't need to memorize all of this. Just use the derivation from the basic um, trigonometric identities, and you have your derivation. So since this is the Laplace transform of sine squared t, so we can use this formula. Okay, this formula meaning to say sine squared t can be equivalent to 1 minus cosine 2t all over 2. This is all over 2, and then we will take the Laplace transform of each term. Okay, but before that, we are going to take out 1/2 and take the Laplace transform of 1, which is 1 over s, minus the Laplace transform of cosine 2x, or cosine 2t is just s all over s squared plus 4. So this is your final answer. This is not difficult. This is actually easy now if you know how to manipulate trigonometric identities. All right. Now let's try another one. This time, we are going to solve for the Laplace transform of cosine. Let's say this is cosine squared t. And we know that cosine squared t is simply this identity. Okay, we have the Laplace transform of 1 plus cosine of 2t all over 2. So to start taking the Laplace transform, we need to take out 1/2 and take the Laplace transform of each term, which is 1 over s, and then s all over s squared plus 4. So this is the Laplace transform of your cosine squared t. Okay, that's it for cosine squared t. Let's have another one. So this time, now let's make it more difficult. Let's make it more difficult. So I have here sine of 2t, then cosine of 3t. Now this is multiplication. So we need to take the Laplace transform of this. Now if you can see, you can actually, you cannot, use, the following, the previous identities, like this one, to solve for number 8 problem. But we will derive another identities for this. Okay, now let's start the derivation. Recall that your sine of a plus b, now take note, sine of a plus b is equivalent to sine a cosine b, right? Plus, okay, cosine a sine of b, right? Yes, of course. Now let's try this one. Let's try 2 and 3. Okay, so let's try 2 and 3. Sine of uh, 2t plus 3t. Okay, we can use this angle, sum of two angles. Okay, this will become sine of A, which is 2t, cosine of B, which is cosine of 3t, plus, okay, plus cosine of 2t, okay, multiplied by sine of 3. That is for the sine 2t plus 3t. Now let's have another one. Let's try sine of 2t minus 3t. So for this is the difference, no, of two angles. So we can just use this sine of 2t, the same cosine of 3t. But in this case, we are going to change the sign to negative. This would become cosine of 2t sine of 3t. Now, if we are going to subtract, take note, if we are going to subtract the two equation, let's label this as your equation 1 and equation 2. Now, what will be cancelled out? Okay, not we will not subtract this. Now, we will actually add the two equations. Let's try. Let's add the two equations. So adding two equations, what will be cancelled out? So this will cancel out. If we are going to add the two equations, this term will be cancelled out, right? Okay, now adding two equations will be sine of, take note, this will become 5t plus this will become minus t. Okay, now this will be equivalent to this term, and this term will become 2 sine of 2t cosine of 3 times t, right? Now recall that sine of negative angles. So sine of negative angles is just negative of sine t. So we can rewrite it in that way. So dividing the whole equation by 2 becomes 2, and this will become sine 2t, and this will become cosine of 3t. That's how you derive equation. Take note, they look similar. Okay, not similar but the same. Okay, now let's substitute the derived for the derived what we call this, the derived trigonometric identities here. So we can have 1/2, or we can have sine 5t minus sine of t all over 2. Okay, now if you will take the Laplace transform of each term, we have, so since 1/2 is constant, we can just take that out, and sine, Laplace transform of sine is 5 all over s squared. So this is s squared plus 25 minus, we have 1 all over s squared plus 1. So I think that this will be now your final answer. All right, so that is the Laplace transform of sine 2t and cosine 3t. Okay, now take note of the derivations because you will be doing this in your activity for today. Okay, now let's try. Let's try to solve another or the last problem. What will be our last problem? Okay, for the last problem, let's say problem number 9. Okay, what is the Laplace transform, no, of 2 raised to t? Okay, actually now this is not found also in your transformation pair, because in your transformation pair, the exponential function, now let's go back to your transformation pair for a while. So this is just given in your transformation pair. This is e raised to at all over equals to 1 over s minus a. That is only given. But in the last problem, we are going to take the Laplace transform of 2 raised to t. So we need to convert 2 raised to t into exponential function e raised to a certain value. Now, if I'm going to manipulate this further, now I will manipulate this. Take note, this will become e. Note that raised to ln no, of 2 raised to t is the same as this equation. Take note in your trigonometry, e raised to ln of x is just equal to x. This is in your trigonometry. So meaning to say, technically it's the same. Now, if we are going to manipulate this to make this one as ln of 2 multiplied by t, ln of 2 here becomes your a, right? So that will be your a, and the Laplace transform for this will become 1 all over s minus a, since a is ln of 2. So this become ln s, s 1 over s minus ln of 2. This will be your answer. Okay, now I hope now you've learned something from this um, lecture. So what did we discuss? What did we discuss for today? What did we learn for today? So we learned how to manipulate trigonometric functions. Okay, manipulate trigonometric functions. Manipulate so trigonometric identities. Identities. So this is what we have learned for today. Learning. So learning. So we manipulate trigonometric identities. We also use transformation pair to solve for the Laplace transform of the function. Use transformation pair. What else did we learn? Um, okay, we have so much learning for today because most of these now will come out in your examination. All right, that's what we have learned for today. Now, I hope now you will also practice solving your activity problems. Now, I will be giving activity problem after this. Okay, now so that's it for today. Now,